I have this one here. It's a good one. We're going to take this reaction and ask a question about it. It's a balanced equation, which is also always important. Okay, what we're going to do is we're going to react 2 grams of aluminum. There's our 2 grams of aluminum. It's our reactant with excess chlorine. There's our chlorine. That's present in excess. And we go into the lab, conduct an experiment, and we have a theoretical yield, or I'm sorry, our actual yield. Let's calculate what the percent yield is. So we have our actual. We need to determine theoretically what we could possibly make, the maximum amount. And what we're going to do is we're going to assume that there's 2 grams of aluminum. And we're going to go through the process of stoichiometry to determine what mass of aluminum chloride we can make from that starting amount of aluminum, assuming that we have excess chlorine. So we're going to go through our steps. Stoichiometry, first step that we're going to do, everyone should be shouting out, let's determine the number of moles of aluminum. And I would be like, exactly, that's what we're going to do. The molar mass of aluminum from our periodic table could easily be found. It's 26.98 grams. And that would tell us that we can react 0.07413 moles of aluminum. So that's how many moles of aluminum we have available to us. Let's convert that to moles of aluminum chloride. Notice the coefficients. There are 2 moles of aluminum for every 2 moles of aluminum chloride. Again, we're using the same problem-solving strategy that we did in our last few slides. And this is the only step where we convert from one reactant or product to another, in which we use the coefficients from the balanced equation. Since each of these are 2, well, that tells us that we're going to create the same number of moles of aluminum chloride. Okay, now that we know the number of moles of aluminum chloride, let's convert that to mass of aluminum chloride. Aluminum chloride has 1 aluminum and 3 chlorine. And I got 133.3. And we're going to multiply that by 0.07413. And I got 9.88. I think we made a mistake here. 3 times. Plus 26.98. Yeah. Made a mistake here. Sorry, folks. This should be less. Okay, let's backstep a little bit. Let's say our actual yield was 8 grams. Can't have more. Sorry. Let's just backstep. Let's start over again on that problem, and let's assume that our actual yield is 8 grams, and we find out that our theoretical yield is 9.88 grams. And let's now determine what our percent yield is. The percent yield is our actual yield, 8 grams, divided by our theoretical yield, and I got 80.97%. That's not too bad. So just one thing, I had the wrong number as the actual yield. Has to be smaller than our theoretical. I think I made a mistake in setting up the problem. Sorry about that. All you want to do is change this to 8 grams, and that goes in our numerator. That's our actual yield. Our theoretical yield is what we've calculated, and we've determined our percent yield using our expression that we defined earlier. If you got any questions about that small mistake, just send me a text or send me an email, or make a post on the discussion board. We'll start chapter 8 next week, and I think we're doing okay. Good luck. Wash your hands.